It's a cold morning in the late 1990s at Ford's Truck Development Center in Dearborn, Michigan. The kind of morning where the air feels heavy, like something big is about to happen. Inside the lab, engineers are standing around a crate the size of a small coffin. Metal, heavy, silent, and inside it is something that will divide opinion for decades. A 10-cylinder engine, not a race engine, not a supercar experiment. A truck engine, one that Ford believes will replace the legendary 7.5-liter 460 big block and redefine heavy-duty power forever. But what they don't say out loud is this: they're not just building an engine. They're trying to build a lifeline for Ford's entire truck empire, and what they create will be powerful, controversial, and brutally misunderstood. But what almost nobody knows is this: the 6.8 Triton V10 was never meant to be famous. It was meant to survive, and survive it did, in ways nobody expected. To understand why Ford even built a V10, you have to go back to the pressure cooker of the 1990s. The truck wars were heating up fast. Cummins was dominating diesel torque. GM was pushing big block V8s like the 8.1 Vortec. And Ford was relying on aging pushrod engines like the 460, a motor loved for its torque but hated for everything else: fuel economy, emissions, and weight. The old guard was dying. Federal emissions standards were tightening like a noose, and fleet buyers, the lifeblood of Ford's commercial truck business, were starting to ask questions Ford couldn't answer. Questions like, what comes next? Because the truth was, Ford didn't have a clear answer. Diesel was expensive to develop and maintain. A new big block V8 would take years and millions in tooling, and the clock was ticking. So Ford made a decision that sounded crazy at the time. Instead of building a brand new big block V8, they would expand their modular engine family. A clean sheet design, overhead cam, aluminum heads, mass production flexibility. And from that family came something unusual: a V10. The decision wasn't made lightly. Inside Ford's engineering halls, debates raged for months. Some wanted to stick with proven V8 architecture. Others pushed for turbo diesel development. But a small group of engineers saw an opportunity. The modular engine platform was already in production. The tooling existed. The supply chain was established. If they could stretch the architecture just enough, add 2 more cylinders, they could create something unique, something that filled the gap between gas V8s and expensive diesels, something built for the real world, not the spec sheet. Built from the same DNA as the 5.4-liter Triton V8, sharing its bore of 3.55 inches and a long 4.16-inch stroke, the new engine stretched itself into 6.8 liters of displacement. 10 cylinders, 2 valves per cylinder, single overhead cam per bank. On paper, it looked almost simple, but simplicity was an illusion, because this engine was about to be thrown into the heaviest jobs Ford could imagine: F-250s, F-350s, ambulances, school buses, motorhomes that weighed more than most houses, jobs where failure meant stranded families in the desert, where breakdowns cost thousands in towing fees, where reliability wasn't a feature, it was everything. And Ford engineers had one question in their minds: can it survive full load every single day? The first prototypes hit the dyno rooms in 1997. The sound was unlike anything Ford mechanics were used to. Not the deep rumble of a V8, not the sharp bark of a diesel, but a rhythmic, mechanical roar, a 10-cylinder heartbeat built for endurance. Engineers stood watching gauges, monitoring temperatures, tracking every vibration and harmonic. They ran simulation after simulation, load tests that mimicked mountain passes, heat cycles that recreated Death Valley summers, and slowly the engine began proving itself. Early versions produced around 275 horsepower and 410 lb-ft of torque. Not impressive by modern standards, not even class-leading at the time. But torque delivery was smooth, linear, predictable. The kind of power curve that matters when you're pulling a loaded trailer up a 6% grade at 3 in the morning. Later updates pushed it up to 310, then 362 horsepower, with torque climbing as high as 457 lb-ft in the strongest configurations, not supercar numbers. But in a 7,000-pound truck pulling a 12,000-pound trailer, it felt unstoppable, at least in theory, because theory and reality were about to collide hard. The first problem showed up quickly: heat. Under sustained load, especially towing uphill, the engine bay turned into an oven, exhaust manifolds expanded, studs began to loosen, and mechanics started noticing something disturbing: bolts snapping inside cylinder heads. Ford's engineers went back to the drawing board. They revised the exhaust manifold design, upgraded bolt materials, added heat shields. But physics is unforgiving. 10 cylinders generate 10 cylinders worth of heat. And cramming all that into an engine bay designed around V8 dimensions meant compromises. Compromises that owners would feel every time they filled the tank. And then came the fuel consumption complaints. Owners were reporting numbers that made them laugh and cry at the same time. 8 miles per gallon, sometimes less. One Ford engineer reportedly said during testing, "We didn't build an engine, we built a fuel pump that moves trucks." Fleet managers did the math and winced. Commercial buyers started questioning the total cost of ownership. And suddenly, the V10 wasn't looking like the miracle solution Ford had hoped for. But the real shock wasn't fuel economy. It was maintenance. By the early 2000s, shop floors across America started seeing the same pattern. Misfires, rough idle, check engine lights that wouldn't go away. And the culprit? Coil-on-plug ignition failures. Each cylinder had its own ignition coil sitting deep inside the valve cover valley. Great for performance, terrible for heat management, because after 80,000 miles, heat soak would cook the coils from the inside out. One after another, they'd fail. Sometimes predictably, sometimes catastrophically. Mechanics learned to recognize the symptoms immediately: the telltale shake at idle, the hesitation under acceleration, the way the engine would stumble like it forgot how to run. And fixing it wasn't cheap. 10 coils, 10 spark plugs, labor costs that made grown men cry. Then came the infamous spark plug issue. Not as violent as the Triton V8's plug blowout problem, but still frustrating. Aluminum heads meant that improper torque during servicing could strip threads or cause plugs to seize. Plugs would weld themselves into the heads after years of heat cycling. Extracting them became a delicate operation. Too much force and the plug snapped. Not enough patience, and you'd strip the threads right out of the aluminum. One mechanic in Texas reportedly said, "If you don't pray before pulling these plugs, you're going to be drilling aluminum for the rest of your day." Shop manuals got thicker. Special tools appeared. Techniques were shared in forums and parking lot conversations. The V10 was becoming infamous. Known for thirst, known for quirks, known for making mechanics rich. And yet, something strange was happening. Despite all of this, the engine refused to die, because when it was working properly, the 6.8 V10 was a beast. In the Ford Super Duty lineup, especially the F350 and F450 chassis cabs, it became a workhorse legend. With proper gearing, it could tow over 12,000 to 15,000 pounds without breaking a sweat. Drivers reported something that couldn't be measured on a spec sheet: confidence. The V10 didn't feel stressed under load. It didn't hunt for gears or overheat on mountain passes. It just pulled. Mile after mile. Hour after hour. RV manufacturers loved it. Ambulance builders relied on it. School districts ran entire fleets on it. One fleet manager in Colorado once said, "We tried diesels, too expensive. We tried V8 gas engines, too weak. The V10, it just kept going." And that word started appearing more and more in owner reports. Kept going. Not fast, not efficient, but reliable in the way that matters most. It started when you turned the key. It delivered power when you needed it. And it survived conditions that killed other engines. But there was always a catch, because every mile came with a price at the pump. And that price kept climbing. By the mid-2000s, emissions regulations tightened. The EPA was cracking down hard on heavy trucks. Fuel standards were getting stricter, and suddenly, the thirsty V10 didn't look like the future anymore. Environmental groups pointed at it as everything wrong with American excess. Competitors advertised their fuel-efficient alternatives, and Ford's own marketing department struggled to position an engine that drank premium unleaded like water. Ford engineers tried to refine it. Better tuning, improved ignition coils, revised exhaust manifolds, slight efficiency gains, variable valve timing was considered but never implemented. Direct injection technology wasn't mature enough, and fundamentally redesigning the engine would defeat the entire purpose of the modular platform strategy. But physics doesn't negotiate. You can't turn a 10-cylinder work engine into an efficient modern power plant without compromise. And slowly, the world started moving on. Diesel dominance grew stronger. Turbocharged V8s became more efficient. EcoBoost technology promised power without the penalty. And Ford itself began working on smaller, more advanced engines. Industry analysts wrote obituaries before the engine even stopped production, but the V10 wasn't done yet. Not even close. The real turning point came in the most brutal environment imaginable: fleet towing tests in the American Southwest, heat over 110 degrees Fahrenheit, continuous load climbing long grades, trucks fully loaded to maximum capacity, running for hours without stopping. The kind of testing that reveals truth. Engines were pushed to their limit. Some competitors failed within hours, overheated, limp mode, mechanical breakdowns. Transmissions gave up. Cooling systems boiled over. Engines that looked great on paper melted under real-world punishment. But the 6.8 Triton V10? It kept running. Not perfectly, not efficiently, but it kept going. Oil temperatures climbed but stabilized. Coolant stayed in range. Power delivery remained consistent, even as ambient temperatures soared. One Ford test engineer famously said, "We don't baby it. We break everything else around it, and the V10 just sits there like it's annoyed we're even trying." And that's where its legacy started to shift. From thirsty and outdated to impossible to kill. Stories started circulating. A utility company in Arizona with V10s passing 300,000 miles. A school district in Montana with buses still running the original engine after 15 years. An RV owner who crossed the country 12 times without a single breakdown. The internet age brought these stories together. Forums filled with testimonials. YouTube channels documented high-mileage teardowns that showed minimal wear. By 2010, horsepower in the strongest versions reached around 362 HP, with torque peaking at 457 lb-ft. Not headline-grabbing numbers anymore. But the engine had become something else entirely. A reliability benchmark, a fleet survivor, a mechanical mule that refused to quit. Even as production slowly wound down in passenger trucks, it found a second life in stripped chassis applications. RVs, utility trucks, emergency vehicles. Anywhere failure was not an option. Fire departments trusted it. Municipalities spec'd it. Companies that couldn't afford downtime kept ordering it. Then came the silence. In 2019, Ford officially ended production of the 6.8 Triton V10. No farewell campaign, no special edition, just gone. Replaced by modern V8 engines and eventually Ford's massive new 7.3-liter Godzilla pushrod V8, designed to do everything the V10 did, but more efficiently. The last engine rolled off the assembly line on a Tuesday afternoon. No ceremony, no fanfare, just another day at the plant. And that was it. The V10 era ended. But its story didn't, because something strange happened after it disappeared. People started missing it. Not the fuel bills, not the maintenance quirks, but the confidence it provided, the way it just worked when everything else failed. Today, the 6.8 Triton V10 has become a cult engine, not for performance, not for efficiency, but for something far more rare: consistency under punishment. Mechanics still talk about it, fleet owners still trust it, RV builders still respect it. Used truck buyers specifically seek out V10-equipped models. Prices hold stronger than comparable diesels from the same era. and online communities dedicated to keeping them running continue to grow. Because while it may not have been perfect, it was honest. It did exactly what it was built to do: pull, haul, survive. No matter how long it took, no excuses, no compromises, no apologies. And that's the real truth behind Ford's 6.8 Triton V10. It was never the fastest, never the cleanest, never the most advanced, but in the real world of heavy loads, long distances, and brutal conditions, it was one of the most dependable engines Ford ever built. A 10-cylinder reminder that sometimes engineering isn't about perfection. It's about endurance, about building something that works when it matters most. About reliability you can count on when you're 100 miles from nowhere with a trailer full of equipment and a deadline to meet. The V10 never won awards, never dominated magazine covers, never became the engine enthusiasts dreamed about, but it became the engine professionals relied on. And in the end, that's a different kind of legendary. So the next time you hear someone dismiss the Triton V10 as just a gas guzzler, ask them this: how many engines can survive 200,000 miles of punishment and still start on a freezing morning like nothing ever happened? Because that's what this engine did, day after day, year after year, through heat and cold, mountains and deserts, loaded and empty. And if you really listen, you can still hear it, that deep, mechanical 10-cylinder rhythm fading into highway noise. A machine that was never meant to be a legend, but became one anyway, not through flash or speed or efficiency, but through something more valuable, through simply refusing to quit. If you enjoyed this story, let me know what you want next. Another forgotten Ford engine, a brutal diesel rivalry, or a deep dive into the machines that quietly built America's trucking world. And make sure to subscribe, because the next story goes even deeper under the hood.